Okay, so here is a quick reminder of all of these principles. They're kind of listed there on the left-hand side of the screen as well. Now, I wanted to mention some things that go deeper than what we have covered so far for odd-sized packets. And in fact, I'm going to talk about something really powerful down here that's not even listed on our table. Okay? And this is something that you can explore and exploit in so many different ways. So anyway, we'll get to that at the end. But so what I've tried to do here, and I apologize because once again I kind of put this together fairly quickly before recording, but I wanted to summarize a few things. So for these odd-sized packets, we have a couple of things going on. We have fixed points, and then we have something called a lone survivor, like that final card that results from a mixing procedure, right? Okay, so over here, so let's focus on fixed points just for a moment. So packet size. Okay, as we mentioned, for an odd-sized packet, the middle card is always a fixed point relative to an overcoding of the cards. Okay, and we took advantage of that in that little routine. The next one we haven't actually talked about before, and it will be an important one to at some point understand because you can just make use of it in so many ways. So what it is here is there's no restriction on the packet size. It doesn't have to be an even number or odd number of cards, which is wonderful. And the mixing procedure we have in mind is the Klondike Shuffle. And so what's the fixed point? It's the bottom card. Now, if you give it 2 minutes or 2 seconds maybe of thought, you'll realize that with the Klondike Shuffle, so let's say the bottom card at the moment is 7 of diamonds. So I'll just turn it over. With the Klondike Shuffle, you're taking the bottom and the top off together. Right, and then you're setting those down. So that bottom card, in fact, it's the only fixed point generally that you'll have. The bottom card will be a fixed point, always, for any packet size, when you perform the Klondike Shuffle. Okay, so because that bottom card is being pulled off along with the top and set on the table, that bottom card just stays there. Well, think about it. If you were to do a few Klondike Shuffles and then maybe do some other mixing where you retain the bottom card at the bottom, boy, hardly anyone would think that you would know where any cards are. And really what you could have done is, you come up with a packet of cards. In fact, you could just go ahead and truly have it mixed where no one knows anything about it. And then what you can do is you can just take it, so watch carefully, take it and you just tap it. Tap it on the table like that. Just tap it as if you're straightening it up. So I don't know if you can see what I can see, but I can see fairly well what the bottom card is. Well, from this angle, it doesn't really look like any shenanigans are taking place. So you just kind of tap that and glance and just notice and then turn away as if you weren't paying attention to anything. Well, you know the identity of the bottom card. Okay, and so with the Klondike Shuffle and other ways of mixing cards, you can reveal that in the end, which will be very surprising because the shuffling that can be done really will convince most anyone that the cards are beyond the knowledge of anyone, right? But yet you know something about the bottom card. And then, of course, that once you know the bottom card, well, there's many things you can do with it, but, just dealing out the cards like this, right? Just dealing them out. Well, you know what this is. You know what that card is, okay? And so, you could maybe, stack those if you like, or whatever you'd like to do, and say, after all that mixing, I'm getting the feeling that one card that has just risen to the top despite all of the scrambling of those cards is the 4 of diamonds. And then you could come up with a reason as to why the four seasons. And diamonds Diamonds are the most expensive. They're the highest on the, list of rare gems or whatever. Okay, so you just use your imagination and your creativity to go ahead and reveal there's a 4 of diamonds. How did he know that? And in fact, how could he have kept track of anything there? Because I saw those cards being mixed really, really well. Okay, so anyway, that's something that I haven't listed over here yet. Now, the lone survivor. A very fun idea as well. So now we've seen some of this already. So for an odd-sized packet, the middle card is the lone survivor for the LR, that's the left-right dealing. So you go left, right, left, right, left, right, and then you retain the odd-sized piles. Okay, you retain the odd-sized piles and then deal those left, right, and then retain the odd-sized pile left, right. You'll eventually get down to just one card on its own. Okay, and that card on its own will be the original middle card of that odd-sized packet. Okay, so we saw that with a packet of 5 cards. Okay, so for a packet of 7 cards, the lone survivor for the underdown deal, that's the she loves me not dealing, it's the bottom card. The bottom card is the lone survivor for a packet of 7 cards relative to the underdown dealing. Okay? So what I want to show you here is I already have recommended that you watch this number file video that talks about the underdown dealing or the lone survivor principle. What I've done here is I've done a screen capture of one of their diagrams, of one of their charts there within that video. So just see one of my previous videos. It's probably the one for 5 cards, right? So for the 5 card packets. Okay, so what I want to show you here is, now within that video they derive this formula. So let me summarize what they've done there. So for the underdown deal, the card or the position of the card that will survive that process of elimination, because remember, you're eliminating, you're saying she loves me not, that one's discarded, this one's discarded, she loves me not, and so forth. Okay, if you happen to have 7 cards to begin with, the lone surviving card will be the 7th card. And let me explain the formula here. The way that you figure it out is you take the number of cards, maybe we'll do it for 10 down here. The largest power of 2, smaller than or equal to 10, is 8. It's 2 to the 3rd. And now you look at the remainder. So you have 2 to the 3rd plus what is 10? Well, it's plus 2, right? So that's our L. So we have 2 to the 3rd plus 2 for L. Will be equal to 10, okay? And then to finish, to find, he calls it W because he calls it the winning position, or you can just, or the surviving position, right? It's the last card at the end of this underdown deal. You take this L, this little remainder, once you've divided it by the highest power of 2, or found the highest power of 2 that's less than or equal to the number itself, whatever the remainder is goes into this little formula here. It's 2 times that remainder L plus 1. So this identifies, this locates the surviving position, or the card, where the card needs, where the surviving card will be found. It will be found in this position. Okay, so for a packet of 7 cards, it just means the bottom card. Okay, so if I do 1, 2, 3, 4, 5, 6, 7. Oh, talk about serendipity there. Okay, so I have 7 cards. So the claim is that if I do this, she loves me not, loves me not, yes, no, yes, no, yes, no, yes, no, yes, it's going to be the original bottom card for a packet of 7 cards. So, so I once again encourage you to watch the whole video, because by the end of that video, he derives this formula that's actually fairly easy to apply. Oh, we should apply this to 5. Do you remember? Okay, because I said it was special for a packet of 5 cards, and it is. So if you think back to when we were working with 5-card packets, the lone survivor for the under-down deal was the middle card. Okay, so that's unusual, as you can see in this chart. Because if you come over here, okay, take 5 and find the largest power of 2 that's less than or equal to it. Well, it's 4. It's 2 squared. And so you have a remainder of 1. You take that 1 and you multiply it by 2 and add 1. Well, it gives you 3. So the card in the 3rd position will be the lone survivor in a packet of 5 cards when you perform the under-down deal. Okay? So really, for a packet of 5 cards, I mean, that was a special property of that particular packet size. So isn't that cool? So anyway, I just wanted to kind of show you that. And once again, see, it goes back to what I said about the Klondike Shuffle. It holds fixed the bottom card. Well, it's not too hard to glance the bottom card of a packet of 7. You know, you just have the spectator give you a bunch of cards, maybe you gather them up, and it's not unusual to kind of straighten up the cards like that. And then you can just kind of glance and see that that's the Queen of Hearts. And now you go through and, you know, do the under-down deal, and with you know, some panache, you know, kind of reveal that, wow, somehow you knew what that final card would be, even though the spectator freely chose these random 7 cards, right? So, okay, so I want to finish on these last 2 statements. These are really interesting. So, given an odd size alternating packet, we'll talk about what that is. Even size coatings preserve the alternating structure. Okay. So why don't we focus on that one first? And then what's interesting is, I mean, the symmetry here is so cool, because now if you're given an even size packet instead of odd, an alternating packet that's even size, odd size coats preserve the alternating structure. So the even and odd just switch. I mean, isn't that wonderful? They just switch places. Okay, so if you get down either one of these, you can just quickly mentally transpose those and get the other statement as well that you could use. Okay, so we're going to show the first one here. Now, it is true that we don't have to work with just 7 cards, right? Because that's really the focus of this particular video. It's any odd size packet at all. But we do need to have an alternating structure in mind. Otherwise, you won't know what you're preserving, right? Okay, so maybe I'll illustrate it with 7 cards, since that's what we're supposed to be looking at in this video. So you can probably see the alternating structure here. It's black, red, black, red, black, red, black, right? So it alternates in color, which is great. Now, if we perform even size coatings, that alternating structure will remain. Now, the cards will be changing positions and moving around a fair amount, actually. But the alternating structure of color will be preserved. The even numbers would just be 2, 4, or 6, since we only have 7 here. So you can tell people that, you know, the even numbers are, they're just nice numbers. So why don't you just randomly choose one of those, and I'm going to mix these cards according to the number that you tell me. So 4, 1, 2, 3, 4. Okay, how about another even number between 2 and 6. 6. 1, 2, 3, 4, 5, 6. Okay. 4 again. 1, 2, 3, 4. And finally, one more. 2. Okay. 1, 2. Okay. Well, let me show you, the performer, what has happened. Well, nothing. Well, no, I have to be careful. I do this all the time. I say nothing happened. Yes, things have happened. Cards have been moved around a bit. Okay, so if you compare them, it's very likely that we did not get back to the same order. I honestly don't remember what the order was exactly, but at the start. But we have a black, red, black, red, black, red, black. So think about it. How could you take advantage of that? They don't know this. They don't know that it's alternating in color. And they especially don't know it's alternating in color after the mixing that involves values that they chose for you to work with. Okay? So, what's one thing you could do? Well, you could just go ahead and do a left, right, left, right, left, right. Well, what's that going to do to an alternating packet? It's going to separate them by color. But guess what? We've done more than that. Unless you were very observant, you may not have realized that not only did we separate it by color, we separated it by evens and odds. The parity of the cards has been separated. Oh, look at that. Beautiful. 2, 4, 6 is right there. Okay. Oh, you can't see the 3. Sorry about that. Okay. Well, I mean, you saw the alternation of the colors. So all I needed to do, if you rewind the video, is, well, you can see what I've done. I've chosen red cards are even value cards, black cards are odd value cards. Okay. Now, you would not necessarily have to do that, though, right? Okay. So now the black and red separation is wonderful. It's very visual. But see, we would not have had to. So, for example, I could have done this instead. So there, we could do that. That's fine. And then maybe a 10 right there. Now I'm needing an odd value right there. And then an even value, maybe a nice little queen, and then an odd value. Why don't we do a red, since otherwise we have 2 red, 2 black, 2 red. I meant to say black. Sorry about that. So it's not so obvious. Okay. We need one more. So why don't we go ahead and just get a red even one. That would be just fine. So maybe we'll bring in that 6. So let me just show you what we have. So I'm just illustrating what we could have done differently. If we were only interested in separating the even values from the odd values, then you wouldn't have to have them alternating in color, right? So this is even, odd, even, odd, even. That's a 12, odd, even, right? And so if we go through and do like 1, 2, 3, 4, so we coded 4. Maybe we'll do 2, 1, 2, and then 1, 2, 3, 4, 5, 6. Now you have to realize that 7 cards aren't very many, right? 7 cards are not very many. But this principle applies to any odd-sized packet, and the principle over here, any even. Okay, so you could have 21 cards here, 51 cards here if you wanted. You could have the whole deck over here, right? So it may lose a bit of impact because it's only 7 cards. But anyway, the point is that now if I do a left-right, I really should separate the even value cards from the odd value cards, right? Because that's how we set it up. So those are all odd valued, and these are even valued. Okay, well, anyway, that's kind of going beyond on the diagram. If you remember, I talk about other effects. There you go, other effects. So we can put this last little bit in that category. So this may be, I really think this one is worth remembering and making note of and playing with it. You know, maybe start with an even size alternating packet, and then you can perform odd size coats, okay? And I do want to point out that you can guide people or make it look like it's a kind of a random thing. So for example, if the person's name is Mary, M-A-R-Y, spell that. You know, if you have an odd size alternating packet, spell Mary. And maybe her husband's name is John, J-O-H-N, you know. So you could even say Mary, M-A-R-Y, is, I-S, very, V-E-R-Y, pretty. That won't work, right? Pretty, no, pretty won't work. Ugly, there you go. Ugly has 4 letters. That won't be a crowd pleaser. So anyway, you can, you know, kind of maybe even have a list of words that you draw from or ones that you've kind of thought through. You could say Mary is very kind, K-I-N-D. So very kind. Or good, G-O-O-D. You know, that kind of thing. Okay, well that's enough for this video. And so, whoa, next time. Oh man, 8 card packets. There's a lot that we could talk about here. So this is next time. And once again, we're not trying to cover everything in every video, but over the course of the videos in the series, I'm hoping to hit all of these ideas well enough that you get the basics, you get the essentials of these ideas, and you'll just be ready to jump into the full-blown Hidden Structures online course. So thank you for watching.